In section 4.6, we're looking at figures and trying to determine if they are similar. Specifically, we're looking at triangles. And so I just want to remind you there are three ways to determine if you have similar triangles. One way is using the angle-angle postulate, which means if two angles in one triangle correspond and are congruent to two angles in a second triangle, then the two triangles are similar to each other. Second way is side angle side and side side side. These use sides, which means if the sides that correspond are proportional or in the same ratio in the first triangle with the second triangle, then we also have similarity. And in the second one with side angle side, there has to be a pair of congruent angles, and those pair of congruent angles must be included between the two proportional sides. So that means the angle has to be sandwiched in between the two sides that are proportional. So in number 2, it doesn't appear that we have anything in this drawing except for parallel lines. Well, with parallel lines, we actually have corresponding angles. So angle, I'm not sure what this letter is up here at the top. We'll call it the letter P. We'll make that the letter P. Angle PGH is congruent to angle PIJ. And in looking at these two triangles, I also noticed that the smaller triangle at the top shares the same angle as the larger triangle. So angle P is congruent to angle P by the reflexive property. Since they share that same angle, those two angles must be congruent to each other. So we're going to say that these two triangles are similar by angle-angle postulate. You're going to see later on where I'm actually going to have you redraw the two triangles that you see in this drawing. I'm going to have you redraw so that you have triangle PGH separate from triangle PIJ. In number 4, we again have a pair of congruent angles that are right angles. So I'm going to go ahead and draw the right angle here in this small triangle. Since these two angles are supplementary, they have to equal 180, so each of those are 90 degrees. So I'm going to say that angle BAE, that's this angle right here, BAE, is congruent to angle DCE, and that's this angle right here. And then once again, they both share an angle in common, and I'm going to name that angle a different way than I named it the last time so that you can see different ways to name angles. I'm going to call that angle BEA is congruent to angle BEA, and that's by the reflexive property. So once again, these two triangles are similar by angle-angle. Here we have a drawing similar to the one that we were just looking at, and we're being asked to find the height of the statue. So the part that we're trying to find out says that Min wants to measure the height of a statue. We're going to call that x. To help us to find that value, I'm going to redraw the two triangles that you see in this drawing separately. So I'm going to start with the large triangle. And then I'm going to transfer the numbers that I know. For example, I know the distance along the bottom here is 84 feet. I'm going to write 84 here. And what I'm trying to find is this value x. And then I'm going to redraw this little triangle right here. I'm just going to redraw that triangle over here and transfer those values. And I notice the base of the triangle is 12 feet. 12 feet is from here to here. And the height is 5. And so now that I have those two triangles side by side, it's easy for me to see a proportion, and it's easy for me to see which sides correspond. So x in the large triangle corresponds with 5 in the smaller triangle, as 84 in the large triangle corresponds with 12 in the smaller triangle. So we're going to solve this equation, we're going to solve this proportion, and that will give me the measure of the height of the statue. And the way that I solve this proportion is by using cross products. So we'll move this over here so we have enough room here. So we're going to multiply diagonally. So the height of the statue is 35 feet. Number 8, I don't need to draw the triangle separately. It's very easy for me to see which sides do correspond. So I'm going to, again, write a proportion. And in this diagram, I notice that x in the triangle on the left corresponds with 5.5 in the triangle on the right, as 19.2 from the left corresponds with 13.2 on the right. So the height of the sculpture is 8 feet. Number 10 does not come with a diagram or a drawing, so we need to make a drawing so that we can set up a proportion to help us define the height of the tree. So the question is, what is the height of the tree? So we'll start with the tree, and I'm not very good at drawing, so I'm just going to make a tree over here. And I'm going to draw a line straight up and down for the height of the tree. And then here's the shadow of the tree, make it nice and long. And we'll form a right triangle with the base getting the shadow, and the height of the triangle is the height of the tree. Now, somewhere over here inside this triangle is a person. And we'll say that this is the height of the person, and this is the length of their shadow. So now we have two triangles, and we need to take the values from the from that problem and place them into the drawing. says that you stand, this is you stand in the tree shadow so that the tip of your shadow meets the tip of the tree shadow on the ground. Here's the tip of each of those shadows. And that is 2 meters from where you're standing. So from where I'm standing right here to the tip of my shadow is 2 meters. The distance from the tree to the tip of the tree shadow is 5.4. So here's the tree, and here's the tip of the shadow down here, and that whole distance is 5.4. And you are 1.5 meters tall. I'm sorry, 1.25 meters tall. All right, so once again we have our drawing.
Denise,
Once again we have a smaller triangle inside of a larger triangle. And to help us define the height of the tree, which I'm going to put over here as x, I'm going to do the same thing that I did before. I'm going to draw the 2 drawings. Let's see if I have room down here. I do. I'm going to draw the larger triangle. Make sure that was 5.4, yes. 5.4 meters. We're trying to find the height x. And here's your height and your shadow. And your height was 1.25 meters, and your shadow was 2 meters. So now I can correspond sides quite easily. X and the larger triangle corresponds with 1.25 in the smaller triangle as 5.2 in the large triangle corresponds with 2 in the smaller triangle. So we're going to cross multiply. So the question is, what is the height of the tree? 3.375 meters. All right, let's take a look at number 12, and hopefully we can probably answer all of these once we answer number 12. First, we're going to find the perimeter of the garden, and in order to do so, we need to find this missing side right here. Because I have a right triangle, and I know 2 sides of the right triangle, I'm going to use the Pythagorean theorem. side length is 105 inches. So to find the perimeter, I need to add all three sides. So in order to answer number 14, we need to figure out the answer to number 13, and I need to find out how many posts I'm going to need to attach my fencing to. So the fencing is going around the whole entire park, and the posts are every 15 inches. So let's start with the side that's 88 inches long, and let's see how many posts we need for that side. So we have 88 inches total. And I'm planning them every 15 inches, so I'm going to divide by 15. So I'm going to need to go about every 6 feet with a post, about every 6 feet. So sorry, not every 6 feet, we're going every 15 inches, which means I'm going to need about 6 posts. All right, I can't have 5.8 of a post. So I'm going to round up, and I'm going to put 6 posts on that side. So let's go ahead and draw those in. I have 6 posts. So there are my 6 posts on that side. Let's check out the side that's 105 inches long. So if I take 105 and divide by 15, since I'm placing my post every 15 inches, that means I need 7 posts. So let's go ahead and draw those in. So I already have 1 right here, 2, 3, 4, 5, 6. So now I have 7 along that side. And then finally the side that has 137 inches. Needs about 9 posts. There's the 9th one right there. So if I go around and count up the number of posts, I believe I counted 19. So now I can answer question number 14. If each post costs $1.25 and there are 19 of them, 19 at $1.25, and then plus I need to buy fencing, which is 70 cents a foot, and altogether we needed 330 feet of fencing. So 330 feet at 70 cents a linear foot. Then we can find the grand total